Hello, students. Now, another day, another video. So, we only got a couple more left. So, let's get into it. This is review of Module 3 assessment. So, we started this in class. We may or may have not finished it. So, we're going to break it down. So, let's begin with reading. A coordinate grid is shown below. Matter of fact, this is a daily work. I just remember what I said in the previous videos. I am not reading this. You need to read this. So, after you read, you are plotting a point. That is to sum it up. The point has an x value, well, an x coordinate and a y coordinate. So once you determine what your x and your y is, put them in place and plot them. Remember, when plotting a point, you do x first, so x-axis first. Then you go from the x-axis to your y-axis, and then wherever they meet, that's where you place your point. All right. On to question number 2. Now, number 2 was mentioned in number 1. You have 2 coordinates. So this is very heavy in vocabulary. So let's talk about that. So x coordinate, because we're looking for the x and the y coordinate. X coordinate just means where is the point based on the x-axis. Now, is it on the x-axis? No, just according to the x-axis, where does this dot fall on that number line? Then you got the y-coordinate. Same thing, but where is the point based on the y-axis? Okay. So we need to figure out where the point is based on the x-axis and where the point is based on the y-axis. And I told you how a coordinate is written on the previous question. So if you don't remember, go back to the previous question and you should be able to figure this one out. Let's move on to number 3. All right, number 3, first thing you need to do, read it and identify what you're looking for. So in this particular one, I'm going to make a diagram. This is select all answers that are possible. That doesn't mean all the answers are correct, but the ones that are all of them need to be checked. So remember when we were talking about sets of numbers, I had you draw 4 circles. The middle circle was natural. The next circle after natural is whole numbers. After 6th grade, they kind of get rid of natural numbers because they are already included in whole numbers. And whole numbers is really only like a difference of 1 number. So the next one after that one is integers. And then, of course, the last circle is rational numbers. Now, remember, we do the dot. The arrow shows me where I can go. So if I'm a natural number, then I also belong to everything else that the arrow is touching. If I'm a whole number, then I'm not a natural number, so I can't go back this way, but I can continue out and be everything else. Same thing with integers. If I start here, I cannot go back, but I can follow the direction of the arrow and go out here, which means I'm also rational. Rational cannot go here, so if it's rational, there's nothing else out here for it to be but a rational number. There are other types of numbers, but they're not connected to these circles. So use these circles to figure out where that number goes. Sorry, I think I got ahead of myself. Nope. Number 4. Any Venn diagram I said I wasn't going to read. You need to read it. Now, since this was a drop-down problem, your answer choices are right here. This is for number 1. So for this one, and then this one is for number 2. Now remember, the Venn diagram is this. The table, of course, or it could be a list. So what did I say when you're doing this one? What's the condition? And then when you're doing this one, what is the condition? Because you have to make sure you're applying the right condition to the form that you are dealing with when classifying numbers, because they don't work the same. Number 5. So read the problem and identify what you are looking for. Point 16. Now, to find 16, what to do. Well, first thing you should do is what I told you to do. When you are given a number line and you have a bunch of spaces with tick marks but no numbers, then you need to figure out what those numbers are worth. Now, I know this is a decimal, but I might do fraction for this one to kind of compare it with. So we have 0 and then we have 0.5. Now, for the sake of this, I might ignore the decimal point and just call this 5 so I can kind of figure out what I'm counting by and then put it, and then look at it as a regular number later. So first off, we need to count. So I'm at 0. It's going to take me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines to get from 0 to 0.5. All right, even if I think about this in by 5, what can I count 10 times and get 5? So since I don't like 5, I'm going to add a 0. All right, what can I count 10 times and get a 50? Remember, I'm ignoring the decimal point. Well, to get 50, if I have to count 10 times, that means I'll count by 5. But remember, this is a decimal point. It's a decimal point. So that is, I might have to do decimal. Yeah, I'm going to have to do decimal. So that'll be 45. You know what? I'm going to type this up. So 0.5. .1. Wait, am I missing one? 5, 10, 15, 20, 25. There I am. I'm wondering why that didn't reach. I'm going to take some space out of that one. All right. So here, 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 and here. All right, I have all my numbers. Now, the one problem with this is I was given a fraction. I wasn't given a decimal. So, is there something we can do to kind of try to figure out what to do? Yes, because fractions and decimals have a close relationship with each other. And if you have one, you can turn it into the other. Remember to convert. It's called convert. So how do we convert a fraction to a decimal? Well, you have to divide. Numerator in, denominator out. Since this is a whole number, you just put your decimal point, bring it up, put your zeros, and then you divide and figure out where it goes. The rest is up to you. All right, moving on to number 6. Number 6, I need you to read it and then identify what we are looking for or what we need to do. Because this one is more of an action, not so much of a find. Graph 2 numbers. Which numbers? 13 1/2 and 13 2/5. Now, this time I will be able to use fractions. So once again, just like the previous question, we need to figure out what each tick mark is worth. So we went from 13 to 14. So that's a change of 1, but we got all these little lines in the middle, so that means these have to be less than 1. So starting from here, count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I have a change of 1 and I had to count by 10, if I change that 1 to a 10, 10 tens, if I'm counting 10 times, well, no, yeah. If I'm trying to get to 10 and I have to count 10 times, I'm counting by 1. But this is not a whole 1. This is a decimal 1. But I'm going to do the fraction version. So we have 13 1/10, 13 2/10. This is 3/10. I can't keep writing 13. It takes up too much space. 4/10, 6/10, 7/10, 8/10, 9/10. Wait, 1, 2, 3, 4. I missed 5. 5, 6, 7, 8, 9, 10. All right, now that I got that going for me, I need to see where these two numbers are compared to these. So I would tell you just to compare fractions. Now, I did talk about this in another video from last 9 weeks, and that means the second 9 weeks, which was from October to December. There are a couple of different ways you can compare fractions. You can turn these into decimals and turn these into decimals if you want to. That's not really necessary. One of the ways you could do this is, since all the denominators equal 10, if you can find a way to change the half and the 2/5 to have a denominator of 10, then that's one way this will work. If you don't want to do it that way, you can always do the butterfly to see if to compare which one is greater. For example, if I wanted to compare these two fractions with the butterfly method, I would multiply this times this. So 2 times 1, this is 2. And this one is 10 times 1, which is 10. Since this fraction has a higher value, that is not the value of that fraction, okay? That is not what that fraction equals. It's just the value compared to the other. Since this one has a higher value than this one, that means this one is bigger. So since it doesn't equal the same thing, this and this are not the same. So that means this does not go here. It has to equal the same number when solved. So if you think about that, it has to equal the same number if you're going to do the butterfly method, or simply try to get the denominator, both of these, to equal 10. And then once you get your numerators, you'll see where they go on the number line. Moving on to number 7. Now, 7 is very long, but you have to pay attention to what's going on in 7. So I'm going to give you a moment to read, and then we're going to, take a moment to read, identify what you're looking for, and then let's continue. I will suggest you pause the video because I am going to be continuing on. So, for this problem, we need an equation. So, what is an equation? Well, an equation is a comparison of two expressions. What does that mean? If you have an equation, that means you have a combination of numbers, variables, depending on if you have to use letters or not, operations, and an equal sign. Now, this actually doesn't give us all our numbers. We have to solve for one of them, as you can see from here. So we're going to have one expression here, and then what that expression equals over here. So make sure you use the numbers provided in the problem. This is why you have to read. All right, going on to number 8. So read what it says and then try to identify what you're looking for. Pause the video because I will be continuing on. Unknown integer. So we are looking for an integer. So it has to be a whole number that is either positive or negative that's going to fit in that blank. Now, I'm not going to help you out that much with this one because it gives you everything you need. It gives you the first number on the number line, and it even tells you where it ends. So how did we get there? You can figure it out. Now, that was number 8. Let's go to number 9. All right, take a moment to read it. Sorry. All right, let's continue. So here, we're looking for a number sentence. Now, a number sentence can either be an expression or an equation. Because it kind of depends on what they're asking you to do. If you look down here, we clearly have equations. So we're looking for an equation that matches these number lines. So make sure you look at the number lines carefully. One of these can be a little tricky, but I want you to use your rules if you need to figure this out, because it's actually not that hard. So remember, adding integer rules, same sign, add and keep, different signs, subtract, and keep the bigger sign. Multiplication and division, you're either going to use the triangle or you're going to use the tic-tac-toe box. One of the two needs to be used, and it's for you to decide. Last but not least is question number, oh no, there's 11 questions. All right, so almost second to last, number 10. Read it and identify what you are looking for. So, order from greatest to least. Now, here's the thing about ordering this from greatest to least, though. We have 2 improper fractions, 1 whole number, 1 decimal, and 1 mixed. So it's a lot of different things going on here. We basically have 1, 2, 3, 4. We have 4 different number forms. And that would be kind of hard to compare and figure out the order if they all look different. Now, for this particular problem, what I would suggest, and this is my suggestion, I would suggest fixing the improper fractions, making them look like mixed numbers at first. And then if that doesn't work, well, I know that will work, but if you need to take it further, then turn them into decimals to compare them past that point. But looking at these numbers, you shouldn't really need to, but if you do, then do that. Now, if you don't remember how to turn an improper to a mixed number, you simply divide the numerator by the denominator. For an example, I need a good one. I'm not going to do these numbers. So let's say we have 20 divided by 3. That gives me 6. That's 18. That's 2. All right, so let's say our improper fraction was 20 over 3. I divided it, and this is what I got. Remember, you start at 12 o'clock, so that means you start here. This is our whole number. Working around the clock will take us to our numerator. And then continuing around the clock will take us to our denominator. So this improper fraction will now be 6 2/3. Okay? And once you do that, if you need to take it further, then turn the fraction into a decimal. But that's only if you need to take it further. That means you have 2, there's not going to be a 6 here, but I would have, like if I had 2 6s like this, I would probably turn the fraction into a decimal to compare them further. Or depending on how many fractions I had, I could just do the butterfly method to compare these 2 fractions to figure out which one is bigger, which means that number is bigger. In the case of this one, it would be 3 times 1, which is 3, 2 times 2, which is 4. This one is bigger than this one, so this one would go first if these were my numbers, and they're not. So I hope that explanation helps you understand what you need to do for this particular problem. Now let's talk about number 10. That was number 10. Number 11, which is the very last problem you need to do for this review. And you just need to practice the solving. So there were 4 operations. There's always going to be 4 operations. And you needed to solve the integers for each operation so you can start noticing a pattern. That's why I did it this way. So I'm going to just give you the rules, and I need you to apply them to the column they apply to. So you have I'm going to type this up. I'm not going to write this. So you have the adding integer rules. Now, here's the thing. I call this adding integer rules. This is just adding rules. Is when you're dealing with positive and negative numbers, because it applies to more than just integers. So, same sign, add and keep the sign. Second rule, different sign, subtract, and keep the bigger sign. And by bigger sign, that means the number, ignore the sign, is the number bigger than the other one. For an example, if I was adding this, I have negative 13 plus 5. Negative 13 plus 5 are different signs because one is negative, one is positive. So that means I have to apply the second rule, which is different signs, subtract. I would subtract these two and that would give me 8. But the thing about it, is that 8 going to be positive or negative? Well, let's think about this for a moment. I had a 13 and a 5. Even though the 13 was negative, I had 13 and I had a 5. Out of the two of those, which one is bigger? The 13. So I'm going to keep that sign because I had more negatives than positives. So it will be negative 8 for the answer. Subtracting integer, once again, is not just integers, it's numbers in general that have positive and negative signs. And this goes for any subtraction because I told you to do this for all subtraction from now on. That way you can start getting used to the skill that you'll need when you get to algebra. Subtracting integer rule, well, subtracting integer doesn't have a rule. It has steps. Step 1, perform KCO. Remember, KCO is keep, change, opposite. Step 2, follow adding integer rules. So once you perform KCO, keep, change, opposite, follow the adding integer rules. Now, for the ones who need a refresher on how keep, change, opposite works, let's say we have negative 13 minus 5. So you would write that out. KCO has 3 letters, so separate this into its 3 parts. We have the number, the operation, and then the last number. So KCO. K stands for keep, so I don't do nothing with this but bring it down. Change means change to the opposite. So that's going to become addition. The opposite of subtraction is addition. And then we need the opposite of 5. So remember, opposites are the same distance from 0. So this is 5 from 0. Its opposite is the same 5 from 0, but it would be on the negative side. So this would be negative 5. And then follow adding integer rules. What are my signs now? I have negative plus a negative. So same sign, add and keep. So add those together. That will give me 18. It was negative because both were negative. All right, last but not least, multiplying and dividing integers. Multiplying and dividing integers. Now remember, there are 2 things we use for multiplying and dividing integers. That's the triangle. And remember, the triangle has 2 negative signs and a plus, a positive. You literally just cover up whatever signs you're dealing with. But remember, The triangle does not do positive to positive solving. So if you have two positive numbers, you just have to remember it equals a positive because the triangle doesn't do that. But it does any negative combination. So positive to negative, negative to positive, and negative to negative. So if this was multiplication and I had two negatives, I would cover these up, which means my answer should be positive. If I had a negative and a positive number being multiplied or divided, I would cover this up, or you would cover these up, and what's left is negative signs. So it would be a negative answer. Honestly, I am partial to the tic-tac-toe box or the box because it has any combination and it works in almost every direction possible. So for the box, you do one diagonal of positives and then every other box is negatives. And then you follow the sign. I did negative to negative. That gives me a positive answer. I did negative to positive. That gave me a negative answer. I did positive to negative. That gave me a negative answer. I did positive to positive. That gave me a positive answer. It works forward, backwards, down, and it even works going up. So this works in every direction you could think of. Negative times a positive equals a negative. It even works on the other diagonal. If this is done correctly, you have everything you need. But many prefer the triangle. And once again, it's more simplistic and I get it. It works though. Both of them work and this one does work. So I'm fine with either. Now, make sure you use the information provided to solve these problems. The only further help I can tell you is this is the adding column, this is the subtracting column, this is the multiplying column, and this is the dividing column. All right. I can't give you any further help than that because that would mean giving out answers. And I already told you I don't give answers. I give skills or steps or a way of thinking. I am to teach you how to think, not give you answers for problems. So that is the end of this video. This is the end of the review for Module 3. I hope it was helpful. If you have any questions, I would suggest you ask your friends who's already finished this assignment. If you don't want to ask them, then you can ask me, and I'll see what I can do. Bye.